Hello and welcome to another video about Unreal Engine 5. In this video we'll make a multiple rocket launcher and we will implement the movement and shooting, and also when we finish we will also implement the predict the trajectory of the projectile. We will be able to make it like this. We're able to predict the landing of the projectile, and we will add also a second camera to for targeting. It's landing in the position that we predict. Now let's start with the tutorial. First let me delete this and make a new one. Make a new folder, call it MLRS. Make a new blueprint, wheeled vehicle point, VP underscore MLRS. Remember to activate the Chaos Vehicle plugin if you are making a new project, because I activated it already. Now to start with, we need to add the skeletal mesh. I will use this merge from the Vigilante content. You will find them for free on the Epic Marketplace. Where is this merge? This one. I will make a new animation blueprint because I already made one animation blueprint. Let's call it merge, or let's call it just merge. Anim blueprint BP. Here, first remember to change the parent class to vehicle animation instance, and we need a reference for the blueprint of this merge to MLRS. Begin the play. Promote to a variable. For now we need the first mesh space ref and wheel controller. Let's go back to our MLRS folder. Now we need to make also a wheel class, front wheel and rear wheel. Wheel, chaos vehicle wheel. Let's call it VP underscore front wheel. MLRS, because I have multiple wheels. Now duplicate it and change the name to rear wheel. Now the front wheel, the size I will increase it to 60 because the tires of the MLRS are large. Well, this is the front wheel. We do not want it to be affected by handbrake, affected by engine, because this vehicle is all-wheel drive, ABS enabled, traction control not needed, affected by steering. This is the front wheel, and uh, I think we will need to change the spring rate later. Let me if we change the weight of the vehicle, we need to change the spring rate. I will show it to you later. The rear wheel the same, increase it to 60 and the width to 30. And we need these rear wheels, we need it to be affected by handbrake and by engine. And do not activate the steering. Also ABS we need. These things will change later, brake torque and other things. Now here we need add spring arm, also camera to spring arm, let's make it 150 or 200. Yeah, 200. And the arm length 1500. It's good, 1500 or 1250. We also need to activate the pawn rotation. Use control pawn rotation. Pawn control rotation. We need let's control the spring arm now. Add control to spring arm. Turn right and left and look up. Add control rotation. This one yo with right and left, and for the up and down add control rotation pitch output. Now because this vehicle is 8 wheels, we cannot use the vehicle component the default one. Let's add the chaos wheeled movement component. This default one, we can only use it if we have a vehicle with 4 wheels or less. If vehicle with more than 4 wheels, we should use the chaos vehicle because it will not work with the default component. Now let's set up the wheels. It is 8 wheels. 1, 2, 3, 4, 6, 7, 8. 8 wheels. Remember, the front wheel should be the first wheels. So the first 4 wheels will be the front wheels, because if you mix them together, you will have problems. Front wheels, MLRS front. Click on browse to asset to make it easier to use the blueprint in these classes. You will click this will take you to the blueprint, and you can just press this arrow here and here, so it will be easier than searching for the blueprint. Here the last wheels should be the rear wheels, MLRS rear wheels. Same here. Now we need the name of the sockets, and we need them exactly. First, don't forget to use the animation blueprint. The new one is this merge. And now let's take the wheels, the left wheels. Let's take this one, this the left front wheel, and change this to number 2, the second front wheel. Now we need the right front wheels. Paste it here and here and change the one to 2. Now the rear wheels, these the left, this is the old one. The rear wheel, left one, and here same, and change this to 4. The rear wheel, third rear wheel, right, here change it to 4. Now we set up the wheels. Let's set up the movements. Let's comment on this. Camera controls. Now move forward. Also do not forget to the engine. We need a torque curve. Let's make a simple one. Add a new key. Let's make it takes 2 seconds to reach the maximum torque. Now here we need set throttle input. Also need to set the brake input. Brake input. Multiply the axis value by -1 to make the brakes go to 0 or below 0 when you move forward, and when you press backward the brakes will be activated and the throttle will be at 0. Now move right or left, set steering input here. Now let's test the vehicle. Let me just add an offset to the spring arm. 400, no, 300. 300 is enough. Now let's test. Sorry, we didn't, we forgot auto possess. Now move forward. Now we need to change the mass offset, mass, center of mass override. Let's make it minus 100 on the z-axis to make the center of gravity lower of the vehicle to prevent it from flipping, and also you can increase the weight, but now I will not increase the weight. Keep it, or let me show you. I will first let's test test it before we increase the weight. Now we can move, turn without flipping. We brakes, go back, turn, go forward. Now I will increase the weight for 15 tons, make it. And let me show you, also we want to increase the engine torque. Let's make it 2000. No. What will happen is when the mass is increased, the vehicle will the wheels will be compressed. Now you see. Let me show you if we have bumps. I will add here small bumps. We decrease the speed of the let me make bumps here. This small bump. If you do not increase the spring rate, the vehicle will be jumpy and with bumps. When it hit a bump, now let's see, it will jump like this. It's like it does not have suspension. So go to the wheels. I think we need to increase the radius also. Go to the wheel, go to the spring rate, increase it. I'll make it 500. The front wheel and the rear wheel also increase the size to 65 and the spring rate to 500. Also the maximum brake torque we want to increase it because we increased the weight of the vehicle, and the torque we increased. The handbrake torque make it 30,000. Brake torque 15,000 and here 30,000. Also add the handbrake, space bar, handbrake input. You duplicate with the control and D. And under engine 4 it was the control W. Now let's see the difference between the spring rate when it was 250 and 500. Now when we hit the bump, it's still jumpy. I think we need to increase the spring rate more, but it's better. Let's make it 750. Here 750. let's move. It's better. The wheels are moving up and down. There is some suspension movement. Before it was stiff, like there was no suspension. Now let's make the let's make the uh, the rocket launcher move up and down and turn. First, let's comment on this vehicle controls. Now we need to make these rocket tubes to move up and turn with the mouse movement. First, what we need is the delta rotation between the control rotation and the vehicle rotation and the actor rotation to take the difference between the rotations and apply it to the sockets of the rocket tubes. But first, I want to tell you that the default physics asset that comes with the vigilante content, it is all kinematic. You need to delete when you get when you open the physics asset. You need to select all bodies and delete and make new bodies, show all bones, and select the select the wheels, or not the wheels, first the main body, they call it cog, and make a new physics asset for it. I'll make it multiple convex, and then you need the wheels. Make it sphere, then hide the bones, and make sure that these bodies all should be simulated to make it work properly. And if you add another body, like for these tubes, if you make it kinematic, it will not work with the vehicle will not work. It will all considered be as kinematic and will not simulate physics, and you will see it hanging in the air. If you want to add a body here, either you add it in the blueprint here, add a collision here to the tubes, or you add a physics primitive here, but you want to make it simulate physics. Also, this will not work because if you add let me show you the launcher. Let's add a body for it. If you simulate, it will fall like this. So you need to set up physical animation, and you do not need all this complications. You can add the collision box in the blueprint. Now that we finish with this, let's go back to our blueprint and set up the pitch and yaw of the launcher tubes. First, let's get control rotation. Control rotation and actor rotation. Now we need delta rotator. Remember, if you reverse these values. If you put the control rotation in the B and the actor rotation in the A, it will give you the same values, but in a negative. It will give you the negative value. So it won't give you a problem, just will be negative. If you turn right, it will turn left. So you need to multiply it by negative or change the position. Now let's break here. Let me, sorry, here. Let's make it here. Now first the yaw. Call it launcher yaw. We need to clamp the yaw or do not clamp it. Here we get the pitch, auto variable, call it launcher pitch. Sorry. Launcher pitch. The pitch we need to clamp it because we do not want it to turn in place more. Before we clamp, I want the movement to be smooth. I do not want it to be jumpy because if you use it like this, it will jump around. Let me show you how. Now let's go back to the animation blueprint to implement it. First, check if is valid, because sometimes the animation blueprint loads before the main blueprint, and this will give you errors. Now we need get yaw, launcher yaw, and get pitch. Promote it to a variable. Launcher yaw and launcher pitch also promote to a variable. Go to the enemy graph, and we need modify transform bone. We need 2. Now the first one, we need the launcher to pitch. The pitch, let's find the arrow. No, pitch launcher. We use the pitch for the launcher and the yaw for the arrow. Now arrow, and here launcher. Now we do not need the translation, and we do not need the scale. We only need the rotation, and use parent bone space. Here the same. We only need the rotation, don't need the scale and the translation. Also parent bone space. Break the construct. Now the arrow, like we said, is the using the yaw. Sorry, yaw, not pitch. And the launcher will use the pitch. Now let me show you the result. Now, like you see, it moves, but it not clamp it. If you not clamp it, it follows the camera movement everywhere. Like if you go like this, it will enter the, it will be, would fall into the vehicle. And you see that the movement is very fast and jerky. We need to make it smooth movement and also clamp the uh, values here. The yaw, let's use finterp 2. This will give you smooth movement of the of your launcher here. The current we use the same as the same value or the same variable, because will start first. We'll start with 0 and we enter an input with the mouse movement, and it will try to match the target uh, in a given time we set. Let's get the delta time or world delta second. The interrupt speed, if you make it 1, it will take 1 second to match the input, and if it's below 1 will be slower, more slower. Above 1 will be faster. I think 1 is good. Now this is the O. The pitch, same. We only change the launcher yaw. We change it to the pitch. Also we need to clamp the pitch. Clamp between 1 and, or make it half and 45. I made it half because we will need the minimum value to not be 0, because when we set up the targeting system we need it to not be 0. If it is 0, it will give us some problems with the targeting of the rockets. Make it 1, better than half. Now let's see the change. Now it's smooth, up, down. Let's not go inside. Yes. Now what we need is the set up the shooting. Let's set up the projectile. Make new actor, call it pp underscore MLRS underscore rocket. Now let's add collision sphere, make it the root component. Collision spheres 32, okay, or 16. 32 I think is big. Add a static mesh. The static mesh, we need it to be no collision. And the mesh, I have, I think, M26. Yes. This this static mesh is also from the Vigilante content. It is free. You can take it from the Unreal Marketplace. Also, let's add a Niagara particle system. Let's use M26 Michelle and put it here. Spawn rate, increase the smoke. Okay, now we need to add projectile movement. The speed, initial speed, 10,000 is enough, I think. The max speed, you can leave it 0, or you can set a maximum speed of your preference. For me, I will leave it 0. And also rotation follows velocity to make it realistic, like when it curves down, the mesh will curve down with the projectile. Also, we need initial velocity in local space. You need to deactivate it because this will help us in the next video when we set up the projectile predicting the arc and the projectile position, or the projectile it will predict the arc of where the projectile land, because I will explain it in the next video. Now let's make the shooting fire. These inputs I already made before. If you do not have, first you need to go to the input settings, project settings, input. For now I will use this old one because I still didn't use the new enhanced where is this, the enhanced input. I still didn't use it. Maybe in the next videos I will make tutorial about it. Here you add action mapping and you choose the button you want. Now fire spawn actor from class. First we need to add a socket to the launcher. For me, I added 12 sockets for all the tubes. If you want, you can only add one socket. How you add it is like this: you add a socket, change its name to whatever you want, and change the position. Let me go to the right better. Change the position, make it here near the barrel, the end of the barrel. And you can add more sockets like this way, and I will show you how to use this. You make the launcher launch a rocket from different tubes. It's easy, not very hard. First you need a variable for rockets, number or available. I'll make it an integer. and duplicate it. And you need the full rocket ammo. The first one, let's call it current rocket ammo. Set them both to 12. Now this MLRS projectile rocket. Now we need the get socket transform. Plug it here to this point transform. Now we need a node to cycle between the sockets that we set up. First we need format it to a variable socket name, and we need to make it an array. Change it to an array. This array we need 12 items or elements. Now we need to put this, also copy the name of these sockets that we made and put them in the array. I will paste and change the number 3, 4, 5, 6, 7, 8, 9, 10 and 11 and 12. Now that we set up the sockets, we need for each loop this loop will every time it will give us a name of the socket. First we need to check if the current rocket more than 0. I think yes, we do not need the for each loop, because if you use for each loop, every time you press the button and fire, the projectile will fire from all the sockets at the same time. No, we need to cycle between the sockets every time we shoot. So first need to get the current rockets and decrease them by 1, -1, and set the current ammo. Now what we need is get a copy, which means get one of the names of the sockets that we have in this array, and how we get the socket name. We get, as you see, we have 12 tubes and 12 rockets, but the numbers here are from 0 to 11. So what we need is the current rockets minus 1 to get these values. Current rockets minus 1 minus 1. Now when it reaches 0, we need to make a delay, let's say 5 seconds. It's like this will be like a reload. We need to get the current rockets and set them to the full rockets. Now let's test. Now go up and shoot. Shooting forward only. Let's see why. Hmm. Uh, the initial velocity in local space we need to reactivate it, and then in the next video when we will predict the projectile path, that time we need to deactivate it. Also we need to move this this subtracting, make it after the spawning of the projectile. Now let's test. Now shoot. Let me decrease the smoke and to let you see. Make it 0 for now. To make you see that the rockets are getting out of multiple tubes. Now let's see. Now for this 1, 2, 3. For this 4. Now to this one change. Now let's make it 250 again. Also, if you want to make it simulate physics, I will make it simulate physics because if you hit vehicles with this projectile and it does not simulate physics, it will cause problems. If an actor or an object that does not simulate physics hits a simulating physics object, that object will fly around and will give you some problems. So you need to simulate it also. When you simulate with physics, you need to simulate generated event. Now let's make it explode. Hit on component, hit system, spawn system at location. the location is this location. Rotation, we need impact normal, make rotation from Z. If the primary axis of the system that you are spawning is the X, you will need to make rotator from X. If it is Z, you need to make rotator from Z. Explosion. These explosions I made before, earlier, in the previous videos. Now let's see. It does not explode. Why? That's the collision. Yeah, we forgot. Block all component. Yeah. Also, do not forget to destroy actor. Now, one last thing I will add. The video is becoming too long, but I want to add this right now, or leave it for the next video. This video is becoming too long. Thank you for watching. Thank you very much.